Well, hello everybody and welcome to today's webinar jointly presented by CPFD Software and Rescale. Today's webinar is entitled Optimize Virtual Reactor Workloads in the Cloud with Rescale. My name is Peter Blazer and I will be your host. I'm going to introduce the presenters after a brief introduction. So let's get started. Today's webinar is being recorded and it'll be available for playback and to share with others at cpfdsoftware.com/resources/webinar, or if you go to our website, click on the resources tab there and pull up webinars presentations. That's where this one's going to live. You're going to see our other webinars, recorded presentations, user conference videos, all available for your use there. So we'll send you a link as soon as that's ready. We want this to be highly interactive, so please type in your questions. If you look on the webinar panel there's the orange arrow will expand that. There'll be a questions tab. You can type in your questions for our staff, and we left purposefully a good amount of time for questions at the end of this webinar. So please don't wait till the end. As you think of a question, as Roque and Sam are talking, type it in, and we will get to those, as many of those as we can. Brief introduction and some of the motivation of why Rescale. Let me first introduce CPFD Software and our product. So here at CPFD Software, we're advancing multi-phase simulation and technology for fluid particle systems such as fluidized bed reactors. These could be gas solid systems, and with a lot of the new features here in released this year, liquid solid systems as well. Barracuda Virtual Reactor models the three-dimensional transient hydrodynamics, multi-phase hydrodynamics, the heat balance and chemical reactions in industrial units, and it's used to improve performance through simulation. So for operating units, these are typically operating 24/7 for years on end, and for such it's used to look inside, determine the root cause of underperformance, reduce the risk of changes through virtual testing, optimize the units. For those of you developing new technologies and bringing those to the market, it's used to broaden the R&D and then more quickly take that technology, commercialize, scale it, and communicate the merits of that technology to all stakeholders. It's used in a variety of industries, broad applications across refining, petrochemicals, materials, gasification, pyrolysis, go down the list. A couple brief examples of typical use cases. On the upper right, I'm showing an FCC regenerator. This is taken from the Geelong refinery in Australia, where they had an issue that was limiting throughput, costing them tens of thousands of dollars per day. Virtual reactor was used to identify the root cause of the underperformance. On the right in green, you can see the carbon monoxide is to one side. Started figuring out why, did virtual testing of changes, and implemented those changes at a turnaround. When the unit started up, they found that the issue was addressed. The operator interventions went down 75%, and they were able to get 4% max daily throughput through the system. Similarly, in the bottom right, this is a cement calciner, and what a lot of people don't realize is something like 8% of the world's CO2 emissions come from the cement calcination process. Now, we need cement. The way to decarbonize this is to substitute fossil fuels, such as coal, for alternative fuels for carbon reduction. But these alternative fuels, often waste-derived streams or biofuels, are lumpy. They move differently through the calciner. So virtual reactor was used here for the European cement plant to increase the thermal substitution rate significantly while reducing CO emissions up to 80%. Now, for all these case studies, that's not the goal of this webinar. There's some footnotes at the bottom. If you're looking at the playback, you can go download papers, play videos, and see all that. Some great case studies there. Now, those are a lot of the historic use cases, but what we're seeing is a lot of use for emerging technologies in the sustainability, renewables, and decarbonization space. These are exciting technologies like waste plastic recycling, chemical recycling of plastics, taking waste, municipal solid waste, for example, and making sustainable aviation fuel, various renewable fuels, carbon capture, the hydrogen economy. And this is a growing area, a fast growing area for Barracuda Virtual Reactor, and one I'm personally extremely excited about. Now, with this technology, virtual reactor modeling, the full 3D transient dynamics, reactions, all this stuff at full scale, how do we do it fast enough to make it meaningful? Most people are familiar with CPU parallelization. This is simply putting multiple CPUs or multiple computers to solve the same system. And this worked really well, particularly as CPU speeds were known to regularly double every 1.5, maybe 2 years. It's known as Moore's Law. CPU speeds would get faster and faster. And then something interesting happened around 2010. Thermal limitations were reached, so you couldn't really shrink and put more transistors in a smaller space without thermal issues. And so then the trend for computers became increasing core counts. Well, when you talk about core counts, this is where a lot of you might think of GPUs. And for those of you not familiar, a GPU is a graphical processing unit used for computer graphics. NVIDIA made it programmable in the late 1990s. In the 2000s, scientific computing, early adopters were looking and saying, hey, can I use this for scientific computing instead of just making graphics? And today's GPU core counts are over 8,000. I got a picture here of an NVIDIA A100 GPU. This has 80 gigabytes of RAM. It has about 8,000 cores on that card. And contrast that with typically well under 100 for the most powerful CPUs. And you can put multiple ones of these in a box. Here's a DGX A100 system. Amazing computer. This one has 8 of these in a single system. And the impact's been really strong. So if you look at this graphic, again, the publication's down there, originally presented at our users conference in 2019 by NVIDIA. We see the single thread performance. This is the CPU increasing on a log plot and then slowing down around 2010, whereas the GPUs are significantly faster and continuing to grow. So what does this have to do with Virtual Reactor? We parallelized our software on GPUs. Single GPU parallelization came out in stages, late 2013, early 2014. Last year, we enabled the software to run on multiple GPUs using the NVIDIA CUDA technology. And here's some benchmarks. The graph here is for 4 different cases, looking at 1, 2, 3, and 4 GPUs respectively, and seeing anywhere between 50, closer to 100 really, and 400 times faster than the CPU using an NVIDIA DGX Station A100. That was last year, our first multi-GPU benchmarks. Then this year, Microsoft Azure presented at Users Conference a case for plastics recycling. At the time, and probably still, it is the largest Barracuda Virtual Reactor simulation ever fully published. And there's a lot of information here, but basically what they did is they ran a huge plastics recycling case and compared multi GPU simulation for, again, 1 through 4 GPUs using the V100s, using the A100s, so different technology on the cloud, on Azure, things that are available, and looked at speed. And the fastest here, the A100 was showing, over 20 seconds per day, compared with 0.04 seconds per day for CPU. That was over a 500 times speed up. And the amazing thing about this is obviously the systems with more GPUs and the newest GPUs are more expensive per hour to run on the cloud. This was the lowest total cost calculation. So because it ran so quickly, the total cost was minimized. And that was an exciting finding. And we're continuing to see gains with advances as NVIDIA improves their hardware and software stack. This plot in the lower right here shows really speed up for a sample case over recent generations of GPUs, and you see that for the same case using the same version of Barracuda Virtual Reactor, the speeds have been increasing tremendously. So as NVIDIA continues to put out new new hardware, software, we're leveraging that. In fact, we have a new benchmark back on Azure by an independent third party, running on 6 A100s on one of their newest systems. This is going to be published soon, over 1,000 times faster. So if a Barracuda Virtual Reactor user wants to run on GPUs, how do they do it? OEM systems are available. A lot of our clients upgrade GPUs from time to time. NVIDIA has their DGX systems. We partnered with Mark III Systems, a company out of Houston, serves around the world. They are a provider of some of the NVIDIA technologies. They work with OEMs as well. So on-premise is not dead. It is alive and well, but it's limited in some regards. So enter cloud computing. Cloud computing really gives users virtually unlimited capacity. They're not limited to the number of cores they have, the number of GPUs, computers. They have instant access to the latest infrastructure. So as NVIDIA keeps coming out, and I'm super excited to see this Hopper GPU coming out very soon, the H100, will very quickly, as those are available in the cloud, people will be able to use them. And demand-based usage models, really where our customers can use the software much more like we do here at CPFD, where there's times when we're setting up one or two, and there's times where we need to run a lot of cases quickly, and they are able to do so. In fact, we've done certain things on Virtual Reactor to enable cloud usage and make that straightforward. So a couple things that came out last year, we came out with cloud serve licensing. So this now, instead of one particular computer being the licensed server, the license sits on the cloud and can be run really anywhere, on your on-premise computer, on a different computer, at home, or on the cloud, be it on Azure, AWS, Google Cloud, wherever. Metered licensing we came up with this year. Metered licensing gives Virtual Reactor users virtually unlimited overflow capacity, so they can run as many cases as they need to concurrently up to the hours available on the meter. And what we're announcing today is this partnership with Rescale, where the Rescale platform can be used then to seamlessly run on any cloud or on-premise, and really takes the complexity out of managing all that out of the hand of the user and just lets them do their job. So with that introduction, I'm going to introduce today's speaker. We have Roque Lopez with us. Roque is a technical account manager at Rescale. He's got nearly 15 years experience working for the turbo machinery design industry. Initially focused on blade design optimization using CFD applications in HPC, and over the past 5 years he's been developing expertise in cloud computing, running CAE workflows that require HPC in the cloud. And joining him will be Sam Clark. Sam's our Barracuda Virtual Reactor product manager. He's been with us since 2008 and is an expert at simulating thermal, reacting, multi-phase gas particle, and now liquid particle systems with Virtual Reactor. As a product manager, he works with the dev team to make Virtual Reactor the best tool possible for our users. High quality engineering support is part of his job. He leads and contributes efforts for the software documentation, leads a team responsible for our training programs, and makes my life a lot easier. I'll just say that. So you're in good hands. I'm going to introduce these guys. I'm going to stop showing my screen and change the presenter over to Roque. So Roque, this should be popping up on your screen here. And can you hear me?
Yes, thank you, Peter. Thanks for that excellent introduction. Well, everyone, welcome, and thank you for being with us today. All right, let me enter slideshow mode. There we go. Well, thank you, everyone. So let me just give you first a quick introduction about Rescale and what is it that we do. So first, let's, I guess both engineers and scientists working in different industry verticals, we're familiar with the design cycle, right? So we either drive the whole design cycle or operate on one of the steps, preliminary design and exploration, validation testing, final optimization, and it really doesn't matter where you are in the design cycle. Most likely, you have to deal with the analytics and the design and the theoretical part of the process. You might probably be using heavily a physics-based simulation software, And of course, if you need to run complex models, complex simulations, virtual twins, you probably need access to high performance computing for the bigger part of your job. And well, if we think of those core elements, for example, CPFD in this case, they would be the software providers giving you a great solution for fluid particle analysis. But then for the compute, well, you have plenty of choices. There is on-prem. There are maybe you can go and try to do it yourself and build your own HPC cluster on the infrastructure provided by AWS or Azure, for example. But Rescale can actually help you with that. So we will be able to provide you a control plane that it's a very simple web application that you can securely access. And we will take care of all the stacks, the technology stacks that are necessary to build in order to, well, to provision in the most cost-effective way infrastructure from the cloud. So for example, once you go into the Rescale platform, and we'll learn that in the demo today, so we have access to a wide library of applications, and we can customize the visibility of those applications depending on your needs. Then hardware selection will allow you to navigate through the whole library of hardware that is available from the different cloud providers. You don't need to create independent accounts with these cloud providers. Rescale will be your bridge to pretty much browse and select what you need. And at the same time, on the back end, we're well taking care of maintaining the fully integrated stack of very secure IT enterprise deployment tools. So anything that has to do with the IT management and the complexity of keeping security compliance and so on, it's going to be taken care of for you by Rescale. And well, with that said, basically the Rescale ScaleX platform, it's pretty much going to be a substitute, if you want to think about it this way, of your on-prem cluster. So instead of having a fixed number of cores on a fixed infrastructure on your own premises, you could have access to pretty much a very simple web page that will allow you to unlock any application, any architecture, and any cloud for your simulations. Now, that's when you would be running, for example, a plain batch jobs. Let's say the scenario where you prepare your files for the simulation in your workstation, and then you offload the simulation in batch to the cluster. You can do that on Rescale at this basic level. However, some applications might require more powerful computing options at your fingertips, right? So we have also Elastic Cloud Workstations. What the Elastic Cloud Workstations will do is that they still allow you to build pretty much any cluster that you need with any hardware infrastructure that is available through Rescale. But it will bring a graphical interface where you can load a full desktop and access this remote virtual machine to load the application, and then if you want, run the full pre-processing, post-processing, and solving a process directly in the workstation. Share that with your peers and maybe work collaboratively, even if people is in different locations of the world. And then, well, you can also access instantly the best GPU-equipped hardware that is available in the cloud. And the hardware selection is really a matter of, as we have here in this animation, just browsing through the hardware list, selecting then the number of GPUs that you want to have for your simulation, and then move on. And we'll learn that today in our demo. One last word about and this is very important. So while you could try to go and do it yourself things with a direct cloud provider, just provisioning the infrastructure, the reality is that that's all your responsibility to keep that environment secure, right? So compliance and security is extremely important for many industry verticals. So we have already certification and compliance with all the major standards. We also include, we also offer a fully compliant ITAR, Gov, and FedRAMP platforms as well. So we can definitely take you there when security is a primary concern in the cloud. All right, so let's get to the exciting stuff. So I have a demo for you today. So this demo, we're gonna review a few scenarios. So I'm gonna show first a Rescale workstation, and we will show you how easy it is to set it up, and then well, start using it for a full CFD and CPFD analysis with Barracuda Virtual Reactor. We're gonna do a pre-solver and post-processing demonstration. Then I will take that one step further and actually share live that workstation with Sam, my friend here at CPFD, and he will take over the workstation and then show you a few cool things with the CPFD interface. And then we can also discuss and show what would you do, for example, in other type of configurations, like imagine that you could have, instead of having a very large, expensive, with a lot of GPUs workstation to do everything, you could have actually a small workstation with a with a cheaper GPU that you can use just for pre and post processing, or you can keep using your on-prem workstation for pre and post processing. And whenever you need to run a simulation that perhaps requires 4 or 8 GPUs, then you just offload that to Rescale as a batch job. So we can show you that today. And then if time permits, we also have a little example of a design of experiments job, which basically what it does is that following the concept of preparing one project and perhaps running an exploration of different parameters. So we will show you how easy it is to parameterize your models on Rescale, and then orchestrate automatically submitting multiple concurrent jobs to explore that design space. So with that being said, let me switch back to the Rescale interface. So once you log in to Rescale for the first time, most likely you will land on our quick start page. Well, from there you can follow some tutorials, and it will be very easy for you to take to get the hang of Rescale. But fundamentally on Rescale you'll find 3 sections. You will find the jobs section, the workstation section, and then your cloud files. Now, if we go to the workstation section, workstations are pretty much virtual machines that you will be able to provision in the cloud on demand, right? And we have a little wizard there, so you can just click on a new workstation when you need to create one, and you can definitely create one from scratch, or you can save templates, and or your administrators can save templates for you, and then you can use those templates as well. So I'm gonna create a new workstation from scratch today, just to show you how easy it is. So I'm gonna call this live. First step is select the software that you need. So today we are featuring a CPFD Barracuda Virtual Reactor. But of course, in this section, if you were on an enterprise Rescale account, you would see the whole library of 1,000 or more applications that are ready to go. But anyway, so I will add that to my workstation. Now, we have been working with CPFD to install and maintain the latest versions. Actually, tomorrow we will have the latest release. I believe it's 22.1. Correct, Peter or Sam?
That is correct. Okay. Yeah.
Yep. So that's going live tomorrow on the Rescale platform. But I mean, for today, we're going to use version 22. As far as license options, so we have most of the software on Rescale, it will be bring your own license. And pretty much, if you have a floating license, you will be able to use this existing license option and then connect via your port and server hostname or IP to your license server. With Barracuda Virtual Reactor, we also have I mean, we also have integrated with their new cloud licensing format. So we are actually able to bring the license as an input with us, and then the system will automatically pick that up. Then the next step is selecting the hardware. So when you jump into the hardware page, here you can see the library of hardware that would be compatible with the application. This is typically hardware that has been validated, tested, and often benchmarked with the respective applications. And then from there you can, I mean, at Rescale, since we are cloud agnostic and we allow you to connect with pretty much any cloud provider, our hardware names are generalized. We call them core types, and well, we're using just mineral names to identify the different hardware instances. But a full description of the chipset, the memory, interconnect, and storage specifications are of course visible to you. So that way you can pick what you need for your simulation. So in this case, I'm going to use a V100 equipped instance, Dolomite. Notice that some of the hardware offerings have this little moon icon that says support suspension. This is an exclusive feature of workstations. Imagine that if you were working on your own portable workstation, right, a laptop or something, by the end of the day, I mean, you're done. So you just suspend the session, close your laptop, and then next day you open it and restart, right? So that's what we can do here as well. So instead of having a workstation running overnight, so you can continue your work the next day, you can just put it to suspend mode and then restart it on the next day. So whenever you see that icon, that's something that is that just means that hardware is equipped to support suspension. But anyway, once you have selected the hardware that you want, then you can just come back here. And in this case, we're interested in selecting GPUs. So adding GPUs as needed for your simulation is just as easy as increasing or decreasing the number of GPUs right here. So for this workstation and this demo today, we just need one GPU. But as you can see here, on a single node, we can bring up to 8 GPUs right off the bat. And then we're gonna set the wall time, right? So you normally will have a sense of how long it's gonna take to run a simulation. Today's example, which is a fluid catalytic cracking unit, that's a simulation that 100 seconds take about 7 hours, 7 to 10 hours to run on this configuration. So I always like to have the wall time, lifetime of the instance, a little bit longer than that. You can always come back here and change the wall time as needed, or if you're done with your work before the wall time, well, you can stop the workstation, collect your files, and well, that will be the end of that cloud instance. And then the next step is where you would bring what you need to work on this remote machine. So you can, if you already have files from cloud storage, well, you can add them from there. So for example, here I could just go on and select first my license file, perhaps a couple of examples, and then add those files. Perhaps I already have a job that I already computed in batch mode, and I just want to load it so I can post-process it on the workstation interactively. So let's do that. I can go back and run and grab my an existing job. And well, as you can see, it's that easy. Just upload what you need also from your computer. We could do that. Bring it from the cloud storage if it's already there, or if it's something that you have computed in batch mode and now you have the need to post-process interactively, just attach the job, and that's it. Then as a final step, you can just select a project. This is projects is just an accountability mechanism for managers to follow, track expense and track usage on the cloud through Rescale. So anyway, I select my project and the workstation is ready to start, and then I hit submit. Here, this is an interesting step. Just before you submit, we just want to confirm with you what's the level of access that you want on this workstation. So you have the option to just restrict access to your local IP address, and well, that's the most secure access. Only from your endpoint you will be able to access that workstation. But for example, if you work on a hybrid environment where sometimes you work on the office or you work from home, or you want to collaborate with your peers to once the workstation is live, then you want to connect from everywhere. And I'll go with that choice today because I'm planning to share a live workstation with Sam. And that's how easy it is to, well, submit and provision your results. I have one workstation that is ready to go. So let me just show that. It's the exact same settings once the workstation has started. So right now, as you can see, the one I just launched is pending, and then it will enter the startup process. But once it's active, then you will see this connect button right there. That will allow you to open a web browser tab. You can also download a connection file to connect directly from your PC with a nice DCV client. But for today we're just going to do the workstation on the web browser. And there it is. So once you load it, it's a fully fledged Linux desktop environment. It's possible as well to install Windows operating system workstations, by the way. But typically for HPC, especially when you're trying to work with large HPC type of systems, well, the Linux, Unix systems are preferred. All right, so the CPFD Barracuda is right there in the launcher on the desktop. We also notice that we also have a few Rescale choices here. So basically, your workstation is a fully integrated self-serve access to Rescale as well. So you can run jobs from here, manage your desktop settings, upload and download cloud files with the workstation through these shortcuts on your interface. So let me launch CPFD. There it is. And perhaps what I'll do is open a fresh project. So I have uploaded here one. So for example, we have the fluid catalytic cracking unit regenerator model. So I can just load that. And well, you guys probably know better the application than me, but I can just, for example, go ahead and generate the grid. And while the grid is generating, let me go back to the workstation settings. And I want to show you here a neat feature, which is sharing. Let's say that, I mean, I'm a beginner with CPFD, so I often bug Sam with questions. And one way for me to get easy help from an expert is just to go on and share the workstation. So you can share workstations and jobs with pretty much any users or teams that belong to your organization. So in this case, I'm gonna try to find Sam, and then I will allow him to take over my workstation via SSH and also interactively. And let's give him a message here, live workstation, help. And I'll share that with Sam. From here, you can also share with teams. This allows you to share with multiple members of your organization concurrently and with Rescale support. And actually, when you share with Rescale support, that will also open automatically a support ticket that we can definitely track and help you resolve. But anyway, let me share that with Sam. And Sam, why don't we show that? Perhaps you can become presenter.
Yes, we'll find the appropriate button here on GoToWebinar. So I'll share this screen. And hopefully that is coming through. It looks like it is. So here, this is a really useful feature of Rescale, and we've been using this quite a bit at CPFD for new user training classes where we can share workstations with people who are attending the class. And that way our training staff can log into workstations and look at it with the customer. So here, this is the workstation that Roque just shared with me. You can see I'm logged into my Rescale account. I went to the workstations section and I clicked on workstations shared with you. And so this is the one that is active, and so I can connect to this. I'll go ahead and click that. And we'll see that what I'm seeing here is exactly the same view that Roque was seeing on his computer. And so if I move windows or start walking through the Barracuda project tree, Roque will also see that in his web browser in a live manner. So that's really handy. One thing you'll notice is that the web browser interface to the Linux desktop here is very responsive. It has a very good resolution. It looks like you're just sitting in front of kind of a regular computer at your desktop. So we've had a really good experience with using these machines.
One note on that.
Oh, yeah,
now that you mentioned resolution, I would like to highlight that we support up to 4K resolution, so you can really and multiple monitors. So you could really have a workstation that is fully deployed, almost like a virtual local machine on your desktop, and with very high resolution.
Oh, cool. I'm still in the 1080p world, but it looks nice on my 1080p monitor as well. Okay, so as we just saw, Roque generated the grid for this particular case. I'll just highlight a couple things. Barracuda has a lot of integrations with our post-processor, which we call TechPlot for Barracuda. So it's kind of a specialized version of TechPlot 360 that's customized for Barracuda users to make things really easy and convenient for setting up and post-processing Barracuda models. So here, after you generate your grid, you can inspect it, you can rotate it in 3 dimensions and all those sorts of things. So this is just like sitting in front of your local machine. We can look at the cells. We can do all the normal things that we would look at for a Barracuda grid. And as Barracuda users would be familiar with, you basically walk down the project tree. You set up all your materials. You set up all your boundary conditions. You define your particles. All these sorts of things. And when you're ready to run, in this particular usage scenario, we're treating this as if it's just a full system that we want to do our pre-processing, run the case, and post-processing on this system. So here I've selected GPU parallel on the run options, and I can just click the run solver button, and it will use the resources that are on this instance. Here we can see that we have a V100 with 16 gigabytes of RAM. So I'll say, yes, go ahead and use that one. And so this, again, it's like using Barracuda on your local machine. And so we'll let that one start up. This is kind of a little bit of a large case, so it takes some time to initialize the particles and all those sorts of things. But while that's going, I'll show you a case that's already fully run, and we can look a little bit at the post-processing and just to show how it's very responsive in that way as well. So I'm going to go ahead and open a project, and this is one that Roque had attached earlier. So if you recall, he attached a batch job that had already completed previously. And so it's just another version of this project, but it's been run out. And so in this case, once you have your results files and you attach them to this sort of instance where you have the user interface, you can go to the View Results button, and this will open TechPlot for Barracuda with the solution as far out in time as the results are available, right? So we can see here it ran to 100 seconds, and we can look at our particles colored by a number of different things, right? Volume fraction, speed, residence time, all these sorts of things. We can look at the cells colored by pressure or velocity or a lot of different parameters there as well. And one thing that you can do is you can load layout files. And so these are a nice feature of TechPlot. I already created one just to highlight a little bit of the types of views that you can get with TechPlot for Barracuda. So in this case, you can use multiple frames. You can show the particles in one frame, the fluid in another frame. This is a feature called slices that lets you show a little bit more of the three-dimensionality of the simulation results. So you can do all those sorts of things. You can also, this particular view is just loading one set of results right now, right at 100 seconds. But of course, you can also load more solution times in as well. I won't load them all right now because I think there's about 1,000 of them, and that takes a few minutes to load up. But here, if we load like 25 results that are kind of towards the end of the simulation, we can highlight kind of the animation features. So here, if we use our animation pane, we can kind of play through the solution times, and we can see the particles moving. We can do all those sorts of things. And of course, you can export animations from this as well, and then you can download those to your local computer. So again, the responsiveness is great. TechPlot in this case is taking advantage of the GPU that's on the system as well. So it looks really nice and crisp, and it's using OpenGL. So yeah, overall a very, very usable interface that's great for using Barracuda. So I'll go ahead and close that one. The other thing that Roque and I wanted to show you is the idea of like starting a case in batch mode, and also the idea of doing the design of experiment. So in order to help with that, I'm going to go ahead and use a feature of Barracuda that's called Save Case As. And the scenario that we want to highlight here is like, let's say that this is case 1 and it has some certain flow rate of gas that's fluidizing the particles in the system. And let's say we wanted to do a case 2 that was a higher velocity of the gas. And so here I'm going to go to my work directory, and I'll put a new folder kind of side by side with our original case, which was the FCC regenerator case. And for the moment, I'll just call it case 2 higher gas velocity. Okay. And the save case as interface, it takes all of the input files that are needed to define the case. And you can also carry around a few other things too. So if we had any script files, layout files, or grid files, we can take those with us. And then we don't need to generate the grid again. And that assumes that we're not changing anything about the grid, right? So let's say case 2 has exactly the same computational mesh, and we're just going to change a couple of settings. So I'll say OK there. And so now it's taken me into the case 2 directory. And let me go to my injection BCs, because this is where my combustion air is coming in. And there's this file. This is essentially just a text file that contains information about time versus temperature and velocity and mass flow rate for this particular boundary condition. So let's say instead of 39 meters per second and 18 kilograms per second, just as an example, let's say I was like, okay, I'm going to go a little bit higher. I'm going to go to 45 meters per second and 23 kilograms per second, you know, and there would probably be some better calculation behind that as well. But let's just say we're bumping these up slightly. And so we'll save that, we'll close that, and we'll say OK. And we can save our project. And then in order to start a batch job, what we want to do is we want to make a tar.gz file out of this folder that has this case. So I'm going to go ahead and minimize that. We can see our other job is running in the background now, right? It took it a few minutes to process all the particles and stuff, but now that one is going and it's running on this local workstation. So if I go to my work directory, there's case 2. So I can create an archive from that. And the type of archive I want is a tar.gzip. Okay. And it can just have the same name as our folder. That's perfectly fine. And we will create that. Okay. So now there's that tar file. And at this point, I'll hand it back over to Roque so that he can demonstrate to us how to do the batch job submission and also how to use this one for like a design of experiment basis as well. So Roque, I'll hand that back over to you.
Excellent. Thank you, Sam. All right, so now I'm sharing my screen. And as you can see here, I kept my web browser open, and actually I could see and follow everything that Sam did, and we are right there. So now let me show you how easy it would be to, let's say we have this workstation, or perhaps it's your on-prem workstation, and it's already saturated using your resources with one simulation, but you always have that extra urgent case that you need to run. And well, you could just run it on Rescale. So the way to run would be, you can use the shortcut here, double click on Run Job from the desktop. And let me see if I properly clicked on that. Oh, there it is. I'm just impatient. But anyway, so we click on that, and that will take me directly to my account on Rescale. And from there, I can create the project, the batch job from scratch, right? I have one template ready, but fundamentally, let's look at here for a moment. The basic steps to start a batch job on Rescale is that you would upload your inputs, which in this case is the tar file that with the project files that Sam prepared. I can then actually, let's do that. So I can upload from this workstation, then navigate to my work folder and grab that tarball. There we go. Well, while that is uploading, I have one that is ready to go. So let me just go back to jobs. Actually, we'll just walk you through the steps with an existing running job. This is the exact same case that Sam prepared, just something that we had kicked off when we started. But anyway, as I was saying, so the first step would be upload your input files. And as you can see here, I have uploaded the tarball, as well as included my license file that I'm carrying with me to connect to the cloud license server from CPFD. And then on the next step, I would select the software, so Barracuda Virtual Reactor, and then I can populate the command line for the batch execution. Now, there is nothing too complicated here, and basically what we're doing is that we're copying the license file to the right location. Then we're changing directory to the project that Sam prepared. Then we're gonna, in this case, I run it from scratch, so we can execute the mesh generation. And then once the mesh generation is done, it will execute the solver with GPU mode, automatic load of memory, and on a single GPU. If I wanted to use more GPUs, I can increase that number directly. For the hardware, in this case, same idea. You would browse your hardware list and select what you need. But in this case, I went for Dolomite with a single GPU. And then those three ingredients is really all you need to run a batch job. Then I hit submit and the job starts. Now, when the job is running, it will take you to the status page, from where you will see a progress bar for the different stages of the job orchestration and provisioning of the cloud infrastructure for your job. And then it will run the simulation. While the simulation is running, you can, we have a live tailing feature that allows you to open text files and then track, for example, in this case, I'm tracking the convergence history of my simulation directly on this web browser window. If you needed more interactivity with the interface, for example, well, not with the interface, but with the program while it's running in batch mode, then we can also open an SSH terminal directly on the web browser. This can actually also be its own independent new window, so you have more real estate to work on that. And for example, here I can go to my work directory and take a look at the files. There's the project that is currently running, and we can see there all the files that are being populated. I can perhaps double check that it's using the GPU. So right now we have one GPU access. It's currently used at 92% by the software, and so on. So you can always interact with your via SSH with your session. And it has also all the logs for the job orchestration. And well, once the job is done, fundamentally what's going to happen is that you will see that the status goes to completed, that the infrastructure has been stopped. And then we have all your output files there, from where you could either start a new workstation or download the job to your workstation for post-processing, or even download that to your local machine to use your files locally, right? Let's see. Let me go back to our workflow scenario. So just to recap today what we have done. So we showed you the full workstation. We share that collaboratively with Sam. I just show you the example where perhaps you're already working on workstation, but you need to offload a new project or a bigger case with more GPUs. So you can do so in batch mode in the cloud. And well, just to give you a quick preview, we also have a design of experiments job type. A design of experiment is job type. I'm just going to show you the template here. But fundamentally, what a design of experiment job type would be that it takes the elements of a basic batch job, inputs, select the software and the hardware settings, but it allows you to, and let me maximize this view here. It allows you to input some, to create some parameters. So for example, here, following Sam's example, we can go to the fluid injection boundary conditions file and perhaps identify the velocity and the mass flow, give some minimum maximum range of exploration with some increments, and then we create a matrix of parameters that we want to run. Then our template file will be, our target would be to modify that little mass flow flow injection boundary condition file, right? So I can edit that file directly in the browser and say, okay, so instead of using integer, the values, the float values for the velocity and the mass flow, let's use parameters. And there they are. And then on the next step, we would just select the software with the proper command. We are just updating the parameterized file. Same idea, changing directory to a Word folder and then executing the solver. And then for the hardware settings, we would select the hardware that we need. But what is neat is that now we can say and take full advantage of the power of the cloud and say, okay, I have enough licenses and I want to run 3 concurrent jobs. So whatever number of simulations I need to do for this design exploration, I want to advance in batches of 3. So you can just increase the number of slots as needed for that simulation, and then use the template to submit the job. And we did a dry run. A dry run is a feature of the DOE that allows you just to make sure that your settings, to validate your settings, and then build the matrix of parameters that that would be explored. So we can see that table right there. And then once you have those results, well, I will tell you the duration of those simulations, the parameters that were done, and then you can grab the solutions on each one of these run folders. And well, that is the conclusion for our demo today. So hopefully, Peter, back to you. Perhaps we have some questions or time for questions.
Thank you, Roque. I'm going to take over sharing here, and I think that's going to have my screen come across, is my understanding. And then before we get to the questions, I'll let you take a 1-minute break. Let me just first tell everybody, if you would like to try Barracuda Virtual Reactor on Rescale, you can. In fact, our training classes are run on Rescale now to just remove that complexity with somebody setting up a computer the first time just to try the software. We regularly run web-based training. It combines hands-on, self-paced practice with interactive live group sessions on Rescale. Our next class is next week. We still have a few slots open, so if anybody would like to join that class, reach out to us. I'll tell you how to do that in a moment. Our next one and the first one in the new year is last week of January there. So register for those classes now, and you can see all the upcoming events on the events calendar on our website. With that, we are going to get to the trainings. Sorry, the trainings. I'm reading questions. The first question is about training. We're going to get to questions, but We got a few minutes here. We're going to get through as many as we can, but please reach out to us. If you are a Barracuda Virtual Reactor customer and want to try Rescale, reach out to your support, your favorite support person, or find us at the team. I also want to point out that Matt Neerman here, the Rescale partner manager, there's his email address. If you have any questions for them, find us and let's try this together. We're here to help. Let's go through some of these questions. Sam, Roque, I'm not sure who's best to answer one. I mentioned training, and there's a question about cost for training classes. So let me just actually address that right off the bat. Yes, training typically has a charge, but if you're an academic, or sometimes if there's open spots a week before, which we are, we're able to get more people into the class. So contact us if you're interested in training. If cost is an issue, feel free to reach out, and if we have open spots, sometimes we're able to do things a week before. So let's talk about that directly. Next question here. Can I use different cloud instances when running the pre-post and solver? I think this came in before, you already addressed that, but Roque, you want to just make that clear?
Certainly. So yeah, the answer is absolutely yes. So you can run pre and post and solver in the same workstations on a homogeneous cluster like we did today, or have a workstation configuration that is perhaps just suited for pre and post, and then offload the heavy jobs in batch mode on a different higher end hardware on Rescale.
And that's really super powerful. So you can take control of your budget there. Speaking of budget, this next question, if two people are using a workstation, I think this is alluding to what you and Sam did in sharing it, does it get billed as two instances if you're both logged in?
Nope. No, definitely not. It's a single instance. And that's in today's example, the owner of that instance, if I say, would have been me. And I'm just using Rescale's collaboration capability to share that with Sam, but he's actually using my exact same instance, so there is no double billing there.
And what's neat is, it's like multiple people sitting around a computer screen, except doing it virtually. I mean, this is why we use it for training. In fact, this webinar is done by 3 people in 3 different cities right now, and it's fairly seamless. So I think that's incredibly powerful for our users. I can answer this one. Do I need a different Barracuda license to run on Rescale? The answer is no. This is not a sales presentation to sell you something different with Barracuda. If you're using Barracuda Virtual Reactor, since last year, we have come out with our cloud serve licensing, and that's the license file you just take along. If you still have an on-premise license, talk to your support team. We can swap that out for cloud served. So it's very straightforward to do that. Are the packages and dependencies compatible with any operating system?
I can try a stab to that question. So the Rescale will manage and be fully responsible for the installation and proper function of the software, regardless of the OS. For HPC, especially when you're trying to scale up to large HPC systems, you will always try to work on Linux, Unix, or operating systems. We also have the possibility to install workstations with Windows as well. But there is actually no problem if your on-prem machine is a Windows PC. I mean, the files are cross-platform compatible, so you can upload them to Rescale, and just don't worry about it. The software will work, and Rescale and CPFD will guarantee that.
I love it. Yeah, no, this really takes the complexity out of it. Trying to hit these fast. There's just a couple more. My company is a preferred cloud service provider. Can I specify the cloud company when running Rescale?
Well, so let me reiterate that Rescale has very strong partnerships. We're more of a control plane to let you access open all the doors of all the cloud providers. So we have very strong partnerships with them to provide you very competitive compute pricing and offerings, right? But that flexibility of being partnered with all of them, it also allows us to, if needed, configure your account with a preferred CSP. If that's your company policy, or even if you already are in the middle of a cloud infrastructure contract with one of the providers,
Mm-hmm.
Rescale can be configured to bring your own compute account. And in that case, well, we would recommend you to have a conversation with one of our solution architects and account executives, so they can tell you more about that bring your own compute configuration.
Great. Yeah, no, I noticed that several of our clients are in the middle of that process, so that's really good for everybody to know. We're at the top of the hour. If we didn't get to all your questions, we'll reach out privately. Let me just say we'll have one last question here, and then we'll end the recording. But just one more for you, Roque. Can I use Rescale or use the cloud alongside my on-premise hardware?
Yes, absolutely. So as we learned today, I mean, you can prepare your jobs on your on-prem hardware, and then when you're ready to submit a large job, you can do it through the Rescale cloud. It's really just a web browser portal kind of thing. Upload files. Everyone knows how to do that, and then from there, the job setup is pretty much a wizard on itself. So you just follow the 3 ingredients: input file, select the software, input the command, pick one hardware, and then you're done. And you can do that with the web UI, or we can also help you to fully automate that via command line. Rescale has a command line utility, and we also have a full REST API support for Python. So we can do something really sophisticated to automate submitting jobs to Rescale with a Python script, for example. And in the necessity of having an integration with your on-prem cluster, perhaps you already have a cluster on-prem and you still want to use that, a full hybrid integration with that on-prem resource, it's also possible. And well, our solutions architects we can help you with that configuration.
Thank you, Roque. And with that, I want to thank you, Roque and Sam, for all your work on this. Thank you to everybody who took the time to join us. This recording will be up within the next 24 hours if you want to share it with anyone. And if you have any questions about either Barracuda Virtual Reactor or Rescale, please reach out to us and we're happy to speak with you one-on-one. And so with that, that concludes today's webinar.